All right, let's calibrate this thing. I've got the user manual here on my laptop. I've got the machine. I'm going to be using the Keithley as the gold standard. So I'm going to compare things against that. And then I have an AC source that I'm going to be using here. All right. So it says the first thing to do is adjust the bias adjust. And you monitor a point and then you adjust it for 6 volts. All right. So we will come here and we will adjust one of the potentiometers for 6 volts. There's 6, 4, oops. Ooh, it's very touchy. And it drifts. How handy. Oops. So this old equipment, you're never quite sure exactly how critical these things need to be. Now, oh, I need to remove the input from the, all right. Let's go back. Oh, oh dear. Let me short the input just to make sure everything's okay. There's a short. All right. Oh, too far. Oh man, this thing is touchy. Okay, go back a little bit. Back a little bit. That's probably close enough, but oops. Oh, it's yeah. It's not exact. I think you just need to get it close. Let's see where that settles down to. What we're adjusting is the bias on the first FET. So it shouldn't be super critical, just as long as you're around 6 volts. But we will try to get it a little bit better than this. Oops, went too far again. And this is the kind of mess you'll get yourself into. You can see this thing just likes to find a happy spot. It's sort of in a feedback loop, so. It's not going that way. I think it was probably adjusted fine before I tweaked it, to tell you the truth. I don't think it's going to adjust easily. It was about 6.2 volts when I started putting a screwdriver to it. Yeah, let's let it go again. 6.1. Yeah, there we go. I'm going to call that quits. We're going to call that good. All right. Meter calibrate. All right. Let's see here. My rotate counterclock. There we go. Okay, so it says meter calibration. Set switch S1 to position A. I think that is the, yeah, let's see here, switch S1 to position A. All right. Not quite sure what S1 is. Anyway, it says the filter should be out and the range switch should be 30 millivolts. All right, 30 millivolts. And set I don't like that we don't have a 0. Not quite sure why we don't have a 0. Anyway, maybe that will come up. Set switch S1 to position. Set the voltmeter calibrator for 30 millivolts, 400 hertz. So, all right, let's just get everything in the picture here because I don't want to go back and forth, back and forth. All right, so we need 30 millivolts and 100 kilohertz. No, we need 400 hertz. Okay, frequency, 400 hertz, amplitude 30, RMS. Oh, jeez. Okay, so we want 0.03, there we go, 30 millivolts RMS. All right. And then we can hook this up to the front. And we can monitor it with our fluke, or our Keithley. So connect the Keithley up. And we'll go to AC volts. And I don't know if you can see that, but the Keithley says 29.95, very, very nice. And now we need to come down here and we're at 29.4. So we need to go higher. And so what do we do? Adjust R2, A2, R62. 62 is the third one over. Okay, third one over, so it's this one, and we can adjust this. Now watch here, here we go. I need to get my head down there so I get rid of the parallax. And there we go, 30. Okay, next step. All right, S1, S2, S1, AB, it's for the battery thing. I'm not gonna worry about that. So it says, now we need to set the test oscillator for 20 hertz. Frequency 20 hertz. And maintaining 30 millivolts, okay. And we see we've gone down a little bit. All right, now we need to adjust R59. R59, okay, we got it. It's this one here. And we can adjust, oops, adjust that one, there we go. There we go, 30 millivolts, all right. Now, now we do 4 megahertz, all right. Frequency 4 megahertz, all right. And the interesting thing is my Keithley can't measure 4 megahertz. It stops out at like 100 kilohertz or something. So 4 megahertz. Amplitude's still the same. And now we're going to adjust C36, which is this one here. All right. And we're going to adjust it. Oh, there we go. Looks like we're kind of peaked out there. 4 megahertz is going to be a bit low, I guess. Meter calibration of the 0.1 range. All right. Okay. Let's see here. Set the range to 30 millivolts, set 100, switches out. Test oscillator for 400 hertz. Hertz. All right, 400 hertz. And we're still at 3. Let's see here. We want to go set the range short. TP1 and wow. Am I on the right page here? No, I'm not on the right page. I need to go back up page. All right. All right, so we set the 20, 59, 4 megahertz, here we go, okay. 30 millivolts, set the range, switch to 30. Adjust the test oscillator at 400. Set the 400 range to 100 millivolts, okay. All right, oh, we're right on 30, that looks good. Now it says short test point 1 to test point 4 and test point 2 to test point 3. This increases the gain of the meter amplifier by 10 dB if the instrument were on the point 1. Adjust indication of 30. Interesting. TP1 to TP4. Okay, 1 and 4. All right, I got some clip leads out. All right, I've shorted out the test points, and now we're going to adjust R68, which is the far one. R68, yeah. And we're going to adjust it to get to the 3 mark. All right. There we go. All right. Now, set the oscillator for 30 hertz. All right. 30 hertz. Oops, I've done something funny here. Frequency, enter number 30 hertz, okay, 30 hertz. Now adjust 59. 59, wait a minute, 58. 58 is the second one, this one. All right, let's measure that one. Ooh, it's flicking around. Probably because I have a screwdriver in my hand, yeah. Oh, it's 30 hertz, that's why. It's just flicking around, okay. 30 hertz. All right, we did that. Attenuator adjustment. The following procedure is used to properly... All right, I think we can take our jumpers out. Okay. Now, following procedure, set switch, okay, set 1 volt, 1 volt range, okay, 1 volt range. Adjust your calibrator, 400 hertz, 1 volt. Okay. 400 hertz, amplitude, oops, amplitude 1 volts. Okay, oh, there we go. And set the oscillator 1 volt. Align 1 volt, 400 hertz. All right, so now we have to reach way inside the instrument and get to the 400 hertz 1 volt thing. All right, and turning that, oh, just fell off. It was deep inside the instrument. Okay. Ah, darn it. It's hard to keep my fingers on it. All right, 1 volt. There we go, 1 volt. Okay. Set the oscillator to 100 kilohertz. Frequency 100 kilohertz. Oops. Oh. Volt. Amplitude 1 volt. Frequency 100 kilohertz. Okay, there we go. Ah, we're getting close, and we need to reach inside the instrument again. I don't know why we're wiggly. Not quite sure about that. That might be showing a bad capacitor somewhere. I don't know. All right. I think we're done. I think we're done. All right. There must be a 0 offset. I'm really worried about that 0 offset, like I missed a step. I don't know why we have an offset. That just seems wrong to me. Maybe not. Seems wrong. Okay, well, let's say 0.6 volts. Amplitude 0.6. See if it goes to 6. Perfect. Yeah, so thing's calibrated now. I don't know why it's wiggly though. That bothers me. I don't know why it's wiggly. Not quite sure why it's wiggly. What is our frequency? 100 kilohertz, yeah. Let's see if it moves. I'm at 0.6 and I'm going to change the frequency. I'm going to move it up. Yeah, it comes back down. 1.9 megahertz. 2.5 megahertz. Very nice. Let's go down. 100 kilohertz, still there. This thing's working really good. 60 kilohertz. Let's go way down. 10 kilohertz, still good. And 6 kilohertz. Let's go down to 60 hertz. Let's see here. Kilohertz. 400. Where's 100 hertz? Yeah, thing's stable from 100 hertz to 4 megahertz. So looks good to me. I think it's adjusted well, and it's not wiggly either. So I think we're done. So I know you couldn't see a lot of that. I was adjusting these 1, 2, 3, 4, 5 pots here at various times, and this one capacitor here for the 4 megahertz adjustment. And then way buried down there that you can't see is the 1 volt adjustments for 400 hertz and 100 kilohertz. They're way down there. But we are all adjusted now, so I like it. Okay, we'll take the handle and stick it on the top, screw it down, and we are done. Nice little unit. If you let me show you something that's kind of fun. All right, so we're going to use this expensive meter here. We're going to go to AC Volts, and we're going to measure this, and it's supposed to be 0.6, and it's 0.97. So this thing's reading. Oh, I got a glare there. This thing's reading really, really good. And if we're right now at 100 hertz, so let me go to here's 10 kilohertz, and at 10 kilohertz, this is bumping around a little bit, and this is bumping around a little bit, so I think that's just fine the way it is. Did I turn on, maybe I turned on AM modulation by, oh, I'm at FSK, oh, I am. I accidentally turned on FSK, that's why it's bumping around. Wouldn't hurt much, but anyway, there you go. Nice and stable now. And it won't affect the calibration. I'm not going to have to redo the calibration. It was just a little bit of fluctuation in the frequency. But let me show you this. Okay, I'm going to go up here to enter 100 kilohertz. So I've gone to 100 kilohertz, and they're both agreeing just fine. Let me bump up to 600 kilohertz, and look what happened over here. We're at 0.4, so this guy stopped working. Let's see here, let's go down to 400 kilohertz. Nope. Let's go down to 300 kilohertz. Nope. 100 kilohertz, yeah, so at 100 kilohertz they both agree, and 200 kilohertz this thing is dying. So the meter, when you use them in AC mode, the AC only goes up to a certain range. You need to read the manual for your voltmeter of what's the highest frequency that the RMS averaging unit still works at. And that's why these were valuable, because they went all the way to 4 megahertz, and everything was fine. So yeah, I like it.